Okay, for the last section of this unit, we're going to take a look at actual problem solving or optimization problems. So the steps to solving optimization problems or min-max problems is you're going to assign variables and you should state the restrictions, because sometimes that's going to eliminate possible values as the question continues. You're going to draw a diagram if possible. You're going to write an equation for the quantity to be maximized or minimized. So whatever the question is asking for a max or a min of, that is the equation that you're designing it around. You're going to rewrite the equation in terms of one variable using substitution, if it's not already in one variable. You're going to take the derivative. You're going to find the critical numbers. You're going to use the first derivative test to determine all max or min values. The answer you're looking for should either be the absolute maximum or absolute minimum, so we can eliminate any critical numbers that are not relevant to that. And then we're going to reread the problem and write the answer down as a sentence, just like we do with all problem solving. So for the first example, it says, find two positive numbers whose sum is 15 and whose product is a maximum. So the first thing is we're going to define our numbers, and I'm going to let x and y be the two numbers. We also know, because it says that it's two positive numbers, that x and y have to be greater than 0 in order to be positive numbers. Now we're going to skip over step 2 because there is no diagram for this problem. But it says that it wants the product of these two things to be a maximum. So for step 3, we're going to state that the product, which we're looking for, which is a max, is just going to be the product of x times y. Now for step 4, we're going to do that substitution so that we can make it be one variable instead of two. And this is where the part where their sum is 15 is going to play into this. If we know that x plus y is equal to 15, then we know that y has to be the same as 15 minus x. So I'm going to rewrite that original equation and say that the product is going to equal x times 15 minus x, or that the product is actually going to be the same as 15x minus x squared. And now I have an equation in one variable. When I get to step 5, we must derive. So for step 5, we're going to derive what we have here. And we're going to say that p prime of x is going to be 15 minus 2x. And then for step 6, we're going to do our critical numbers. So for our critical number here, we're going to say that 0 is equal to 15 minus 2x, which means that x is going to equal 15 over 2. Then we get to step 7. For step 7, we're going to do our first derivatives test. So we have 0 for our restriction. We have 15 over 2. And reasonably speaking, if you put in saying that the maximum here would be positive 15 because they're both positive numbers, that's appropriate as well. I'm not going to dock marks for not including that. But we know that numbers cannot be less than 0. So I'm going to pick two numbers that fit within this region. So like 1 and 10. And then I'm going to see, well, if p prime of x, when I sub in for 1, I get a positive number. When I sub in for 10, I get a negative number, which means that my p of x is going to be increasing, then it's going to be decreasing, and here at the change, I'm going to have a max. Which means that x is equal to that 15 over 2 at the max. Y is going to equal 15 minus x, or 15 minus 15 over 2, which is also going to equal 15 over 2. And then I do my statement. The two positive numbers with a sum of 15 and a maximum product are 15 over 2 and 15 over 2. For example 2, it says find the dimensions of a rectangle if the perimeter is 28 centimeters and the area is a maximum. Well, what do we know about a rectangle? We know a rectangle is going to have the length, it's going to have the width. That diagram is technically our step 2. And when we define our variables, we're going to say let L equal the length, let W equal the width, and 0 is less than L or W, which also has to be less than that perimeter because they're going to be smaller than the perimeter. Step 3, it says it wants an equation for a maximum area. Well, for maximum area, that's just going to be length times width. And for our step 4, we need to turn that into a one variable equation. Well, for the one variable, I'm going to state that if the perimeter, which is 28, is equal to 2 length plus 2 width, then 2 length is going to equal 28 minus 2 width, which means that the length is equal to 14 minus the width. And I'm going to sub that back into the equation. The area is going to equal 14 minus the width times the width, or the area is going to equal 14 width minus width squared. When we get to step 5, we must derive a prime of W is going to equal 14 minus 2W. And then we're going to use this for our critical numbers. So I'm going to say that 0 is equal to 14 minus 2W, which means that W is going to equal 7. I'm going to do my first derivative test. And I'm going to pick my test points. 1, 10 again. And my A prime W is going to be positive. Then it's going to be negative, which means that my A of W is going to be increasing. Then it's going to be decreasing, which means that that is a max. So that means at the max, W is equal to 7 centimeters, and L is going to equal 14 minus W, or 14 minus 7, which is also going to be 7 centimeters. Therefore, when it says what is the maximum is going to be 7 times 7, which is 49 centimeters squared. The dimensions of the rectangle will be 7 centimeters by 7 centimeters with a maximum area of 49 centimeters squared.